Hey Math 2, I've got a new video for you. It's all about how to graph quadratic equations, which are ones that bear the form y equals some constant a times x squared plus some constant b times x plus a constant on its own. So anybody who bears this form is gonna be talked about in this section. So 3 real questions to start out with. Parabolas, what are they? The axis of symmetry, what is that? And then plotting points, how are we going to do that in particular with these quadratic equations? So I'll start with the first question. What is a parabola? Well, a parabola is a symmetrical curve that either swings like a pendulum in this way, or it's like throwing a baseball and seeing it drop on another side of the field. So it's like parabolas are U-shaped polynomial functions that have symmetry. So they are, we'll just call them U-shaped symmetrical curves. And it's vertically symmetrical. And they look like this. They all bear that equation right there. All right, second thing, the axis of symmetry. Well, the axis of symmetry is basically a vertical line that cuts the parabola in 2 equal parts. The axis of symmetry, it's a vertical line that slices or cuts the parabola into 2 equal parts. Which is short to say, whatever distance this point on the parabola is from that axis of symmetry is going to be the exact same horizontal distance that this point is from that axis of symmetry. So if I plot one point, I've instantly got the other point. You'll see how that's a nifty little thing. And then plotting points, how do we do that? Well, the idea is, one more thing. Axis of symmetry also has a formula. Since it's a vertical line, you'd say it's x equals some constant. Negative b, which is the b from the equation here, divided by 2 times a. That part right there. Okay, so the axis of symmetry then becomes a very important part for plotting points. Okay, to plot points, what we need to do is make a table of values that's centered around the axis of symmetry. That's centered around the x equals negative b over 2a. So here's what that would look like. You've got your table. X and Y. I'm just going to require 5 points. 1, 2, 3, 4, 5. The centerpiece is going to be your axis of symmetry. So the axis of symmetry goes right there in the middle. And then from there, you basically spread out. I pick a point here that's left of it. I pick a point here that's right of it. Those y values should be the same because they're centered around the axis of symmetry. You guys will see how that works in the examples that we got. So I'm not going to go in any further than that. But the big idea here is the middle part is going to be that x value you get when you take negative b over 2a. So let's just dive right into it. So I'm asking you guys to graph the function using a table of values like this. So what we do is we first recognize that this is the same as y equals ax squared plus bx plus c, in which these two pieces of information are going to be the driving force of graphing it. So I start with my axis of symmetry, x equals negative b over 2a. That's going to go smack dab in the middle on my table of values. The b value is going to be 4, so it's going to be negative 4, all divided by 2 times my a value is 1. So negative 4 divided by 2 is going to be negative 2. Okay? So that x equals negative 2 is going to go in the left-hand middle part of that column. Now, how do you find the y value? Pretty simple. We take the x that we obtained and we plug it into the expression we see up here. Okay? So to get the y value, I'm going to take y equals negative 2 squared plus 4 times negative 2 plus 1. And you guys can put that in your calculator if you want to. It should be pretty basic mental math though. 4 minus 8 plus 1. 4 minus 8 plus 1 becomes negative 3. So that all becomes negative 3. This means that the starting point for my parabola is going to be the ordered pair negative 2, negative 3. And this gives us our axis of symmetry now. I've got a vertical line that's going to be symmetrical or equal distance to that green line right there. So now what we do is we say, hey, I'm going to pick points that are very close to negative 2, negative 3. So I'm going to say, let's pick the x value negative 1. All right? So the x value negative 1 would be down here because it's right of negative 2. Littlest numbers start at the top and move downward, get bigger. So if I plug in negative 1 for this expression again, that will give me the y value. So this would be 1 minus 4 plus 1, which turns out to be negative 2. So negative 1, negative 2 is this point right here. And then this is where you have to have the presence of mind to say, if this point is 1 unit away from the axis of symmetry, I only have to go 1 more unit to the other side to plot another point that will also be on the parabola. I call them partner points. So negative 1, negative 2 is going to be a partner point with negative 1, 2, 3, down 2. All right? So this is what symmetry looks like for a parabola. All right, and then I'm going to plot one more point just to fill out the chart. Hey, plugging in 0 makes the most sense to me. So I'm going to do try 0. 0 squared plus 4 times 0 plus 1. It turns out to be 0 plus 0 plus 1. 1. So 0, 1 is my final point. And I'm counting 2 from the axis of symmetry. So I'm going to go over 2. And its partner point is all the way over here, which is going to be negative 1, 2, 3, 4, up 1. And that's it for example 1. Now make sure you create a curve like this, and not really like jagged, sharp points, okay? This is not a sharp turn type curve, okay? All right, let's try this again with number 2. All right, so you know what? I'm just going to use the same graph for 1, 2, 3, and 4. So right now, I'll just say this one's number 2. So number 2 is y equals 2x squared plus 4x plus 3. Exact same procedure comes from this. So you're going to do negative b over 2a to find your middle value. Okay, the b value is 4. The a value is 2, so 2 times 2. Well, this is negative 4 over 4. It's negative 1. So x equals negative 1 starts it out, and then I'm going to plug negative 1 into the expression 2x squared plus 4x plus 3. So this becomes 2 minus 4 plus 3. That turns out to be 1. So my first point that I'm going to plot is left 1, up 1. And there's my starting point for this parabola. I now know it's centered around this axis of symmetry, and I'm just going to pick points 0 and then 1 and then find their partner points. So I'm going to pick 0 and I'm going to pick 1, and then their partner points will be left 2 and left 3. Okay, so plug it in 0. 2 times 0 squared plus 4 times 0 plus 3. That's a pretty simple calculation. It comes out to be 3. So 0, 1, 2, 3 is my ordered pair. If I try 1, I get 2 plus 4, which is 6 plus 3, that's 9. So I got to go a little bit off grid here. I'll get rid of this right here. Over 1, up 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's an estimate of where we're at. Okay. So again, you are 1 unit from the axis of symmetry, so you're going to go 1 unit left in the same vertical location. So that would be negative 2 up 1, 2, 3. And then for negative 3, it's going to be you're 2 away from the axis of symmetry up here, so you're going to go 2 away from the axis of symmetry up there. And you've got left 1, 2, 3, up 9. And then again, we're going to make our curve not pointy, but curvy. All right, let's check out number 3. Give me a second. Well, I'm having trouble getting that table up there, so I'm just going to redraw it. All right, same thing as what we normally do. You've got your A value, your B value. Find my axis of symmetry to start this thing from the middle. So it's going to be negative B, which is 12, over 2 times A, which is negative 3. This gives me negative 12 over negative 6, which is positive 2. Okay, so x equals 2 is going to be my middle value. Plug that into the original equation, just like before. So, I will let you guys calculate that on your own. All right, here we are. Negative 12 plus 24 is 12 minus 8, which is 4. So 2, 4 would be our first point. 1, 2, 1, 2, 3, 4. This represents our axis of symmetry. We're going to pick points that are to the left of it and to the right. So I'm just going to say try x equals 1 for this one. So if you're talking small numbers would be left of or above here. All right, so if I try 1 instead of 2, That's going to be negative 3 plus 12, which is 9, minus 8 is 1. So 1, 1, 1, 1. And then it has a partner point on the other side of that. So it's 1, 2, 3, 1. And then I'm going to try 0, because that's another point here. And if I zeroed all of these, it's just going to make a negative 8 right on the y-axis. So you're going to have 0, negative 8, and then 2 away here, go 2 away there. I'm going to have a point at 1, 2, 3, 4, negative 8. Not my best looking curve, but it works. All right, last one. Why don't you guys try this last one on your own, pause the video, and then see if you match up with my solution at the end. All right, unpause. Let's try number 4. All right, y equals negative 1x squared minus 6x minus 4. Okay, so my axis of symmetry is negative b over 2a. A negative negative makes a positive, and then it'll be 2 times negative 1. Okay, so you got negative 3 right there. So that will be the middle of our table, the starting point. All right, so 1, 2, 3, 4. The middle is going to be negative 3 to start with. Just remember, plug that negative 3 back in for x's. So if you do that, and hey, let your calculator help you if you're a little bit confused on that end, you are going to get negative 9 plus 18, which is 9, minus 4, which is 5. So negative 3, 5 is going to start us out. 1, 2, 3 left, up 1, 2, 3, 4, 5. That establishes our axis of symmetry. Now we pick points that are close to that axis. So I'm going to go negative 4, that would be left, and negative 2, which would be right. Makes more sense for me to plug in the negative 2 than the negative 4. So plugging in negative 2 gives me a negative 4 plus 12, which is 8. 8 minus 4 is 4. So negative 2 up 1, 2, 3, 4 is a legitimate point to plot. It's 1 away from my axis of symmetry, so I go 1 away in the opposite direction. That gives me negative 4, 4. Okay. My last point that I'm going to plot is I'm going to check x equals negative 1, plugging it into the expression right here. And that should give me negative 1 plus 6, which is 5. 5 minus 4 is 1. So negative 1, 1. And that's 2 away. And you go 2 in the opposite direction, you get your final point there. 1, 2, 3, 4, 5, up 1. Left 5, up 1. There's my table of values. There are the 5 legit points. I've got my axis of symmetry. And there's my graph. Hey, thanks for watching, guys. Hopefully that was helpful. Cleared up some confusion, and you guys are good with rolling through the homework. Be advised, some of you need to rearrange the standard form on the homework problems. So don't forget to do that, because you'll get wonky answers all the way. All right, we're pushing 20 minutes, so I'm going to say goodbye. Adios.